Welcome to Understand the Math. In this video, I'm going to show you how to solve linear inequalities in a way that's easy to understand. We're going to walk through these 5 examples step by step so you'll know exactly how to solve them. I'm also going to show you why the solution makes sense by looking at a graph. Let's get started. We're going to start with a basic example. 3x plus 4 is greater than 10. I'll begin by writing down the equation. 3x plus 4 is greater than 10. Solving these types of equations is just like solving linear equations, except instead of an equal sign, you just have an inequality sign, but you do the same thing. I'm going to begin by moving our constants to the right, so I'm going to subtract 4 from each side. This gives us 3x is greater than 10 minus 4, which is 6. Now I'm going to divide both sides by 3 so that we can get x by itself. And this gives us x is greater than 2. Often with these types of inequality problems, you may be asked to write your answer in set notation or interval notation. So I'm going to write it both ways. This is how you would write it with set notation. It's x such that x is greater than 2. Or if you use interval notation, it looks like this. You have a parenthesis because there's no equal sign, and then infinity. Now what I want to do is look at the graph so that we can understand why we got the solution that we did. Our red graph is y is equal to 3x plus 4. And then our blue graph is y is equal to 10. Our inequality says that our 3x plus 4 has to be greater than our 10. So that means our solution is going to be where our red graph is bigger than our blue graph. And that's going to be in this part right here. 3x plus 4 is going to be bigger in that region then y is equal to 10. Now let's connect this back to the solution that we got, which was x is greater than 2. What we have to do is just trace down, and this is the point 2. So our pink graph is going to be bigger than our blue graph whenever x is in that region, and that is x is greater than 2. I think it helps so much when you can see it visualized. Let's now look at our second example. In this example, we have 3x plus 7 is less than or equal to 1. So we have a less than sign and an equal sign. To start the problem, let's just write down our equation. We have 3x plus 7 less than or equal to 1. We're going to solve it just like we do any other linear equation. Let's pull our constants to the right. So we're going to subtract 7 from both sides. And this gives us 3x is less than or equal to minus 6. Now we need to get x by itself, so we're going to divide both sides by 3. And this gives us x is less than or equal to minus 2. Let's write this in set notation. Our solution is x such that x is less than or equal to minus 2. Or we can write it in interval notation, which is going to be minus infinity to minus 2, and then we need a close bracket there because negative 2 is included. Now let's go ahead and let's look at our graph. Our red line is y is equal to 3x plus 7, and then our blue line is y is equal to 1. And our inequality says that our red line has to be less than or equal to our blue line. So that's going to happen in this region right here. It's going to sit below the blue line. And then we need to see what x value this corresponds to. So let's take our intersection point and let's trace down. And we can see then that the x value is going to be these values less than or equal to 2. Let's now look at our third example. I included this example because it involves dividing by a negative, and you have to be very careful when you divide by a negative when you're working with inequalities. Let's begin by writing down our equation. We have 3 minus 4x is greater than or equal to 5. Let's move our constants to the right. So we're going to subtract 3 from both sides. This gives us a minus 4x is greater than or equal to 5 minus 3, which is 2. Now we're going to divide each side by negative 4. I'm going to put a star right here because this is super important. When you divide by a negative, you have to switch your inequality. So this becomes x is less than or equal to minus 2 over 4. And then we can simplify this and we get x is less than or equal to minus 1/2. Writing our solution in set notation, we have x is such that x is less than or equal to minus 1/2. Or we can write it in interval notation and go from minus infinity to minus 1/2 with a closed bracket at minus 1/2. Now let's look at our graph. Our red graph is our 3 minus 4x. So this is y is 3 minus 4x. And then our blue graph is y is equal to 5. Now we want our red graph to be bigger than our blue graph. So that's going to happen in this region. Our red graph is going to be bigger than our blue graph. And then we're going to trace down, and that is at minus 1/2. So we can see that our x value is going to be anything minus 1/2 or less. Let's now look at another example. You might want to pause the video and see if you can do this one on your own. I bet you can. We're going to start doing just like we have been doing. We're going to write down our equation first. X plus 1 is less than 6 minus 4x. Let's get our x's to the left. So we're going to add 4x to both sides. And this gives us a 5x plus 1 on the left is less than 6 on the right. Now let's pull our constants to the right. So we're going to subtract 1 from both sides. This gives us 5x is less than 5. And then we divide by 5. And we get that x is less than 1. Our solution then looks like this. We have x such that x is less than 1, or minus infinity, comma 1. Now let's go ahead and look at our graph. Our red line has a positive slope, so our red line is going to be this function. And then our blue line has a negative slope, so our blue line is going to be that function. So we want our red line to be less than our blue line, and that's going to happen in this region. Notice that that portion is less than that portion. Now we're going to go to that point of intersection and we're going to trace down. That hits at x is equal to 1, which agrees with our solution. And that means that our x values are going to be any value less than 1. Hang with me. We have one more example, and it's a little bit more complicated algebraically. Here's our last example. You can see the algebra is a little bit more complicated, but we can do this. We're going to start just like we did before, and we're going to write down our equation. We have 2x minus 3 is greater than x plus 2 divided by minus 3. Before we start moving x's to the left and constants to the right, we need to simplify this so we're not dividing the right-hand side by negative 3. So what we're going to do is we're going to take both sides and we're going to multiply by negative 3. We have minus 3 times 2x minus 3. Now we have to be really careful. I'm going to put another star here. When we multiply by a negative, we have to change the inequality. So instead of a greater than, we have to change it to a less than. And then we'll multiply that side by minus 3. Whenever you divide or multiply by a negative, you always change the inequality. Now we can go ahead and clean things up. Minus 3 times 2x is minus 6x, and then minus 3 times minus 3 is a plus 9. And then we have a less than. The negative 3's cancel, and we're just left with x plus 2 on the right. Now we're going to pull our x's to the left, so let's subtract x from both sides. And this gives us minus 7x plus 9 is less than 2. Now let's move the 9 to the right-hand side, so we subtract 9 from both sides, and we get minus 7x is less than 2 minus 9, which is minus 7. And then the last thing we need to do is divide both sides by minus 7. We're going to put another star here. We're dividing by a negative, so again, we have to switch the sign. And this gives us x is greater than 1. We'll write our solution as x such that x is greater than 1, or interval notation 1, infinity. Now let's look at our graph. Our red line has a positive slope, so it's going to be this function. And then our blue line has a negative slope. And notice this is a minus 1/3 x, so that's a negative slope. So our blue line is our right-hand side. We want our red line to be bigger than our blue line. So that's going to happen in this region because our red line is bigger than our blue line. And we're going to trace up. And we see that that hits at the point 1. So our solution is all x greater than 1. And that's it. I hope that you now feel more comfortable solving linear inequalities and have an idea of how your solution makes sense graphically.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.